Good evening, everyone, and welcome to today's session. So today, like we always do, we have our speaker here already. He has written for us. He has so many things he wants to teach us that he's ready to talk to us about today. So let's stay back and enjoy the process. Please note that the meeting is not being recorded, and yeah. So if you want to get anything or any points, please let's take note of that and get our points documented when the speaker is I started this session. So as much as possible, let's take notes, let's ask him questions because he's here for us for today. And that will be it from me. Okay. The recording session has started. Okay, so thank you. It's now being recorded. Thank you. So what do we do when we have a meetup like this? We're always introducing ourselves, introducing the speaker, and all. So welcome to the UNILORIN R User Group, and we're glad to have you here. So our agenda for today is we're welcoming everyone to join us about the UNILORIN User Group and our users group organizers. We are meeting them and the meetup pretty much. So about the UNILORIN User Group. So we are thrilled to have you joining us here. This is a platform or a community or a user group where we share knowledge, where we talk about some of the beautiful things within the R that we can use and how we can implement ourselves. And our mission here is to foster the use of R in data analytics, data science, and its impactful application across diverse fields such as business, health, and research. So, and that's why we're always having this meetup, get people to come and talk to us about the usefulness of the R and yes, so we can implement it in every basis of our life or our career, whatever we're working on. Yes. So thank you. So the aim of the group is to boost robust community of data science, artificial intelligence, and machine learning professionals and academics. So through collaboration, mentorship, seminars, trainings, and conferences. So we are committed to nurturing talents and driving innovation in these fields. So at every point, we want each and every one of us to please collaborate as much as possible. We can collaborate. Collaboration is key. We need to meet people and learn to work together as a team. So no one can be a sole learner. We can't do everything on our own. So that's it. So let's embark on this journey in the world. So how to join us? We have group, we'll see group to the call, chat of the call while the session is ongoing on. So we can be able to join the group if you are not there yet. But if you are there yet, then you're fine. So this is how you can meet us. And currently we have over 600 members and that is still growing. We are kind of a fast growing community and we intend to do that. So if you know somebody that needs it, please share with them and welcome them to the platform. Thank you. So here are organizers that are making this session happen. We have Dr. Garba, we have Adele Lawal, that's me, your co-host. Then we have Mr. Ezekiel Gudipo, is the co-host also, and Dr. Farumbi, yeah, he's also a co-host. So we bring this to you and trust you enjoy the process. So our code of conduct is very still remain the same and it's very simple, expected behavior and unacceptable behavior. So we it can adjust to some of these conducts. We don't want anyone to feel disrespected. We want to treat everyone with courtesy and consideration. We want to honor different views and experience. We don't want to talk down on someone's idea. We want to avoid demeaning and discriminating or harassing behavior or speech. And so unacceptable behaviors that we don't condone at all, offensive comments or insult related to gender, sexual orientation, disability, race, age, or religion, appearance, or any protected characteristics. So we don't want any of that to happen. Deliberate intimidation, stalking, or following. Harassment, harassing photography or recording without consent. We have to get your consent before we can record. And that was you can see the meet will tell you this meet is going to be recorded. So if you don't want to be consented, you can just tell us. So inappropriate physical contact or sexual imaginary and sustained disruption of talks while the speaker is ongoing. So we appeal with everyone to always mute their mic as much as possible when the session is going on. Yeah, this was our last session where we had an hands-on with R on data cleaning in R with regular expression. So today we are going to our session where we'll be introducing our speaker to us. Please, a round of applause as we introduce our speaker. Yes. Please, an emoji or something. I want to see some emojis, please. Okay, thank you. So our speaker is Mr. Babatunde Adebayo. He's a seasoned data scientist with over 7 years of experience spanning business intelligence, data engineering, and machine learning. Currently with Retail, a leading embedded finance and B2B platform operating across multiple countries. He leads end-to-end analytical initiative for both fintechs and retail products, transforming data into actionable insights and powering customer engagement. Babatunde specializes in designing and automating reporting dashboard, ETL pipelines, and predictive models, which enable truly data-driven decision making across organizations. His technical toolkit includes R, Python, SQL, and by platforms, augmented by proficiency in cloud environments such as AWS and Azure. Beyond his work in the industry, Babatunde deeply invests in building communities and sharing knowledge, and that's why we have him here today. As an instructor and project lead in data science community, he actively promotes continuous learning, collaboration, and innovation. So, a round of applause for our speaker, please. Yes, so that's our speaker, and it's going to be giving us insights today. Welcome, Mr. Babatunde. Mr. Babatunde, please, can you confirm you can hear us, please? Okay, so today he's going to be talking to us about mastering deploy in AR, wrangling, transform, and analysis data with deploy. So let me just call it dplyr. So he's going to give us a deep
dplyr.
dive into that. And Mr. Babatunde, you have the floor, please. Thank you.
Hi
Please, a
everyone.
round of applause for him as he comes up.
Hi everyone. First of all,
Yes,
first
thank
off,
you.
I want to say thank you for inviting me to this wonderful show.
Mr.
I'm
Abatunde,
very
your speaker is not
Yes, we can
audible.
hear you.
very good.
It's not audible, Mr. Babatunde.
Try
You're
change
not
it. Is it better
audible.
now?
Please check your microphone, check everything.
Is the microphone okay now, please?
Yes,
Oh,
yes,
yes,
better,
please.
better.
Oh, awesome. I'm saying thank you for inviting me to your group, and I hope we enjoy this session together. Thanks for that wonderful welcome. And without further ado, I wouldn't want to waste our time, so I would like to share my screen if that's okay.
But that's fine. Please go ahead.
All right.
Thank you.
Let me know when my screen is visible.
All right, thank you. Please, if you have any question while Mr. Babatunde is going on with his session, please drop it on the chat of the call so we can pick it from there and ask him as the session goes by. Thank you. You have the floor, please.
Can you confirm my screen is visible, please?
Definitely it is.
Awesome. Okay, today we want to talk about something interesting, wrangling, transforming, and analyzing data using R, specifically using dplyr. And yeah, so I think I'll skip this part. That's been done already. So it brings us to the first question of the day. What is dplyr? Of course, a lot of people pronounce this differently, but I guess it's just dplyr, something like that. So it's a core package in the tidyverse ecosystem. So tidyverse ecosystem is an ecosystem that supports the tidy data philosophy or principle, which I'm going to get to very shortly. Why do we like dplyr? Why do data scientists using R love dplyr? The first reason is dplyr is makes data analysis, data wrangling very readable, and it has some intuitive verbs. For example, if you want to filter your data, you just use the verb filter. If you want to select some specific columns in your data set, you use the word select and all like that. So it's kind of like very readable. It also have like a consistent architecture, and it's able to work with other packages in the tidyverse ecosystem, such as stringr, tidyr, and lots of them. It's efficient. As a matter of fact, it's fast. And the good thing about dplyr is you can use it with a lot of backends, such as not limited to data frame alone. You can use it to connect to your database. You can use it to analyze your database data. You can use it to speak to portable files like Arrow, Packet, just to mention a few. So yeah, it's a very powerful tool to have in your arsenal. That being said, we can move forward in this with this talk without measuring the pipe revolution. So before now, if we are familiar with the base R syntax and all, it's quite like a lot when you want to get things done faster, smarter. As a matter of fact, if you are not comfortable creating multiple variables, you might not be able to flow along using the base R functions and all. So I have here, the first code I have here is a nested traditional approach. Let's say I want to read some data and I want to filter at the same time. So I have to use something like head, select, filter, and all. So it's kind of messy. To that, that's where we have the pipe function. And basically is a dplyr way of saying you read this as though you're reading English or any language you're comfortable with. Before now, we have the traditional magenta pipe, and it looks like this. Pipe, you have something like percentage greater than percentage, and you'll be able to filter or do or chain a lot of functions together. But more recently, we have this new pipe function, and it's basically something that looks like this. To that, it makes it readable, it makes it easy to comprehend what or flow you're doing. In this case, imagine I have a data called car data. I'm able to filter the data, say I want all data, all rows whose year is greater than 2020, 2015. Then I'm interested in some selected columns, and I'm just returning the first 10 rows or something. So yeah, so we can't go on without saying something around pipe. So the pipe plus dplyr gives you something very nice, readable code. For other people in using other languages like Python, for instance, I think the pipe is also possible there, but the convention is not as beautiful as you will have it in R. And that's why sometimes I prefer R to a lot of languages, especially when it comes to data wrangling. All right. You recall the other time I mentioned the word tidy data, and I said dplyr follows it. It was built around the tidy data principle and other functions like even rvest and other functions, other packages in R. Recently, I now built other tidy data principle. So what's tidy data principle? Tidy data principle is more or less speaking to a tabular data. Let me just put it in a simpler context. And it's not just a tabular data, it must also have some form of characteristics. For example, each observation or cases in your data set must occupy its own row. Another thing is each variable must have its own column. So it's not nice for you to join two columns together and just say it's a variable or something. And lastly, each value has its own cell. Perhaps during the talk, should anyone ask question around this, I am happy to answer the question. But yeah, this is the tidy data principle. I know I'm going a bit fast. I have some goals. So yeah, if I'm too fast, please feel free to stop me and just drop a message in the comment section and I will just do justice to that. All right, what's our today's mission? Today we want to master the essentials of dplyr verbs, and we're gonna do this using real data. So to not just be theoretical, it's going to be real data. Perhaps anyone wants to follow along with the coding. I don't know if anyone is interested in that. That we try to see if I can drop the data set link on the group, if that's okay. I just did. So the data set we'll be using is gotten from Kaggle. and it's all about Nigerian used car marketplace. So I'm going to show us how the data looks like shortly. And the data contains 1,400 listings of cars. In it, you have the make of the car, like the title or the name of the car they want to sell, the model of the car, the year the car was made, the mileage the car's traveled, the price of the car or the listing price, the location, what is the import status of the car, the engine type, and transmission. Perhaps you have anybody here who is not a car person. Sorry, I'm using this example, but I'm just guessing we made to the car at least see them on too. All right. Yeah. For you to use dplyr, you can actually install dplyr as a standalone library. And I think the basic rule is just to say install dot packages and you just type in dplyr. It's fine. However, it's always nice to just load or install tidyverse. Within tidyverse, you have loads of other tidy packages, so to speak, that follows the tidy data principle. Example is what we are treating today, which is dplyr. You could have other ones like stringer, stringi, rest, and lots more. Tidyr also. So yeah, for my case, to use dplyr, I'm just loading the entire library, tidyverse. And from there, uh, the link will be able to as data as with the card data using it, showing us what the data set looks like. The data set contains the following columns, 10 of them. And as said, it has more than 1,451 rows. The title, as discussed earlier, you have something like Toyota Corolla, Acura MDX, Lexus EX350, and so on and so forth. The odometer is just like how much mileage the car has traveled, and this is in numeric. So if you have it in lower number, that means the car is brand new, sort of, and it has not traveled much. The location where the listing is happening, Lagos, Abuja, and the likes. The import status of the car is the car local. If used to be a local car means, I think traditionally we use second hand, call it Tokumbo like that. Then engine is for enthusiasts like four cylinder and the likes. I don't want to go to that. But the one I think we can all relate to is an automatic transmission engine or a manual transmission engine. What kind of fuel does it use? Is it petrol, diesel, even electric if we have it in the data? And is the color of the car tag here as paint? What's the price of the car? What year was the car made? Up until this point, I would like to take a breather just to confirm if I'm still audible and if there is any question so far before we get our feet wet.
Yes, we can hear you and you're audible.
Also, hope I'm not too fast. I feel I'm fast.
Yeah, a bit, but we'll get the slides. Thank you.
All right.
You can
Great.
take it a bit smaller, a bit lower a bit.
All
That's fine.
right. Could you confirm how much time I have? I want to have that earlier, so I know how slow I can be. You can confirm
You-
that via chat, so I know.
Yeah, you can just go on.
All right. Okay. All right. I don't want to boss, so let's get started. So let's talk about dplyr. So generally, dplyr is regarded to as grammar of data transformation or grammar of data wrangling. We all know the popular package ggplot2, which we call grammar of graphics. So in the case of dplyr, is grammar of data manipulation, so to speak. For those who are familiar with Python, this is the pandas of R, so to speak. So you literally will not do anything with a tabular data without using dplyr. And if you have been manipulating data that is data frame like in R and you have not been using dplyr, I can tell you you are missing a lot, especially those with base R knowledge. And that's the reason why we have this seminar. For this, we're not going to be doing something too too serious? Yes, we usually we get the presentation slide. No issues with that. For this, I will assume that we have a mixture of those who are beginner as well as those who are expert. So I'll just stay in between. So I won't be saying too much um, big grammar. I just want us to get the basics. Perhaps we've been using it and can just like look at it together. Again, it's collaboration. So I also want to learn from us as well, how we've been using dplyr. All right. So basically, in dplyr, all the functions are regarded to as verbs, and they are kind of like organized into the kind of operation they perform on our data set. So they are basically some functions of verb that are used or applied to rows in the data set, while some are on columns and others are kind of like a group operation thing. So for those that are rows, perhaps you are interested in saying what's the change in observation. For instance, in that case, let's say what are the changes in our data cars? Can we select some or filter some cars? Can we arrange them? Can we slice them and whatnot? In terms of other operators or verbs, we have the column operators. Example is select, mutate, rename. We will get to each of them shortly. And we also have some other operators of verb for grouping and summarization of the data that we are working on. So yeah, the last one is for tables. So perhaps you have like two data sets and you want to like work with both of them simultaneously. Perhaps you want to join them together, you want to manipulate them together, then you will start needing some join or table operators, which often come with an underscore join suffix. You can have like your inner join, outer join, left join, full outer join, and the likes. So for those with SQL background, this is just an array of doing SQL join, so to speak. All right, so let's start working with rows. So the way I've prepared this presentation is both hands-on and explanation. So everything is just together. And if you want me to do live coding, I don't plan to do so. So yeah, it's all just there and the code works. That's what I would say. So let's go to the row operations and let's see what we've got. So here I'm now going to slow down so we get to know what we are trying to talk about here. Like I said, I will assume we have beginners and experts, so I'll just be in the middle. So if what I'm going to say is something you already know, please don't be offended. And if what I'm about saying is relatively to you, then good for me then. Okay, so the first function we are going to talk about under row operations is the filter function. So think of filter, as direct as that. So filter is what you use to like for example, you have some conditions that you want to drill down your data on. You can use a filter operation. You also have another function called arrange. So arrange is
I
as the
think
name
your
sounds.
network is a bit down.
Oh, am I still audible? Sorry. Can anybody hear me else, please? So
Yes,
Please,
you
can
can
we hear
hear
the speaker
you.
clearly? A reaction.
Yes, you can hear him. I think it's your network, Adela. I can hear him. Please go on.
all right. Okay, I can see there's a lot of activity in the what's it called in the chat. So please, if you don't want to unmute, you can drop messages on chat as well if I'm still with you. So like I said, arrange. So it's kind of strange to explain the dplyr function verbs because the name is, in my view, self-explanatory. So how am I going to explain the word arrange rather than just say reorder rows by column value or something? Even the explanation is going to disrupt the name itself. So you just want to arrange your columns or rows, then you use the arrange function. Another function is the slice. Perhaps you just want to slice your data. You just want to select some portion, say on the top 10, top 20, or you just want to select between the 10th row and the 15th row, for instance. We're going to use your slice function. Then this is one of the most greatest function in other this session, which is the distinct. Perhaps you are manipulating your data or you are doing some form of exploratory data analysis. I think you need distinct a lot. For instance, you want to check duplicate and like that. So yeah, let's go to your data bouncer, the filter function. So the syntax is straightforward. The first argument should be your data frame or data, and other arguments are just your filtering conditions. So I will give what this operator without this. Example of the operators is the double equals to sign, which is you checking if a column meets a condition or some columns meet some conditions. The opposite of that is an exclamation sign with an equals to, which says this is not equals to something. All right. Next is you have your classic greater or equals, greater or less than symbol. Perhaps you want to do is something lesser than something, then give me all the rows that meets the condition. And the modification or enhancement to that is less than or equals to or greater than or equals to. So in cases whereby you want to do multiple checks, say for instance, you want to see if you want to select rows in your car data set that is like meet some condition, like is it Toyota, Mazda, and the like like that, they are going to use an in operator. So you can be able to filter a row or a column precisely if it is within your set of list, so to speak. Next is NA. Perhaps you are interested to say, okay, which of your columns or your rows are NAs or something like that. Then if now starts to join a lot of things together, say you want to filter by multiple conditions, you either go with an AND or an OR condition, or both sometimes. Or you can just say those that doesn't by sign. Why do I take my time to explain this? The reason is you might need any of these functions, and you might need to even change any of these operators together to achieve your set goal when you are featuring your data. So I'll give us an example. Let's say in our car data set, our goal is to find Lexus EX350 cars in Abuja. That's our goal. To do that, in the data set, if I can go back there, the column that has the title or the name of our car is the title column. And what we are doing is we are checking, so the title, is it Lexus EX350? So I'm using the double equals to. So the common mistake here is a lot of people, most people have done this before. They will just say title with a single equals to, and it will say is it lost or something. So that will not work because that's an assignment operator. But if you want to do a logical check, then you are going to use like the double equals to. You can use a comma to add or append another condition. And the next condition I'm asking is, okay, I'm looking for all cars that are Lexus EX350, whose location, like listing location, is in Abuja. So yeah, that's on my filter. This is just extra. I'm only trying to select. We'll get to select operator later. I'm saying that, okay, give me the title, give me the location, give me the price, and give me the year. So, and you will have your beautiful result in this manner. All right. Let's move on. So, it will have been nice for us to do some practice. Like, what if we want to find all foreign used cars from 2015? Let me see if I can go to the data set. Let's see if I can get that quickly. Oh, yes, I think it's after here. Yeah, remember, these are the columns in our data set. And if our goal is to look for cars that are locally manufactured, locally used, then I know what I'll be targeting is either locally used or foreign use. Then if I'm also interested in cars that are like the year of manufacturing or the year of manufacturing or make is 2015, I know I'll be needing these other columns. In other words, if I need all cars that are foreign use, so what I'll be doing is to say I'm going to filter this my car data where where it's imported is foreign use and the year is 2015 or greater than 2015 in this case. So yeah, that's the idea. And how are we going to solve that? We are going to solve that to have this set of results. So I'm going to expand the code now. Again, I'm rushing, I know. I could have asked like if anybody can just tell me how the code is going to look like. But because of time, I'm just going to say we are going to do it this way, say car. So I'm piping now. So the pipe function will make this car data set to be the first argument in this function. And if that is the case, so what I'm doing is I'm featuring the car data set, and I'm featuring only cases whereby the car is imported, that is the status or use of the car is foreign use, and I'm saying when the car is 2015. However, you can, yeah, 2015. Then I'm only interested in selecting the title of the car, the year it's imported, and likely the price the car is being sold at or listed at. Okay, before I move to arrange, please can you confirm I'm still with you? So I won't speak, I won't be speaking to myself. Please, am I still audible?
Yes, please. You're audible.
All right. So let's go next to the arrange function. The arrange function is also, or verb, is also for row manipulation. Imagine you want to sort the cars from the newest to the oldest, and you're going to use the arrange function. Again, I'm using the pipe function. Again, I'm using the pipe function. As such, the car becomes my first argument, meaning I'm arranging the car data and I'm sorting by year. But this time around, since I want the newest first, I will add a support function called DESC. This is to just sort the year in descending order. In descending order means the highest number comes first and the lowest number comes last. So to that, we know, like, for instance, this data is not clean. You can see something like 2626 as the highest data, year in this data set. So we know it's not that very correct. But yeah, it gives us a sense of what it is. And this can inform us when we want to really, really clean up this data. So we'll be able to say, okay, you know what? Maybe there's some things I need to fix in this data. Maybe I need to remove some things that looks weird or whatnot. But yeah, the syntax is straightforward. Give the arrange verb or function your data. Then what columns do you want to sort by? Again, you can sort with multiple columns, not just one column. But for this simple example, I'm only sorting from the newest year to the oldest year in this data set. All right, so by default, it sorts by in ascending order. So if I do not have this support, and I only say year, so what you can expect to see is the first year or the oldest. In this case, it could be 1919 or something, will come up first.
Sorry everyone. We kind of lost the speaker. Yes. Please let's give him a moment to join back. I think it's his network. Please just give him a moment to join back, please. We lost your audio at some point. Please, can you retry?
Am I audible now, please? So just trying to answer the question, can we find all foreign used cars from 2025? So the way I interpret this from 2025 is not exactly right in this case. I could have said when year is greater or equals to 2015. Sorry, my bad. So what I answered here is to say, give me from the car data set, filter the car data set such that the its import status is foreign used and the car is made in 2015. So then that's the way I'm going to answer it using dplyr. I'm moving next to arrange. So arrange is just to sort your data. And like I said last time, you can sort your data using more than one column. So you can sort them by 5, 6, 7, 8 columns. And the default way or order as the data is being sorted is in ascending order. Ascending order means like or the smallest first, then the largest last, something like that. And if you want to change this default ordering characteristics, you are going to add this special function called DESC, that is to say descending order. To that, you will then get the biggest number first and the smallest number last. An example to use this kind of function is, or verb is, say for instance, I'm looking for the newest cars, like the first newest cars or first 6 newest cars. So what I'm going to do is pick my car data set. I'm going to sort by year, but I'm going to sort in descending order of the year. And this is how you're going to do it. This particular one, we've not gotten there. So we've not really like gotten to like get to selecting data columns. But the idea is I'm interested in just the title, the year, and the price. So in doing so, I'm also then say the results I have here, I want to select the first 6 rows. So here I'm using the classic add function to just examine the data. And that's what we see here. And I was saying that you can see from here, 2026 is not a year that is it's not like saying a car in the future was made or something. So there's some bad data, so to speak. So that can give us an idea of, oh, you know what, the year data is not looking good and there's something we need to do to it. All right. Yeah, let's continue. I'm gonna move on next now. Yeah. So the slice verb or operator is kind of similar to your head and tail and sample function in base R, but it can just take it a bit further. So say for instance, I want to select the first 3 rows in the car data set, and I'm only interested in title and price column. I'm going to say car becomes the first argument in this function, slice head. Then I'm selecting the first 3 rows. And that's how I'm going to do it. However, let's say I'm not really interested in the first 3 rows, but I just want to select just 3 rows at random. To that, I'm going to use slice underscore sample, which is going to sample the entire car data set and select any 3 at random. Your set.seed is also useful here. You can still use it so that each time you run this kind of code, you're going to get like the same result. But in this case, I'm sorry, if you run it, you're likely not to have the result I have here because we are all selecting as random. All right. So do we have other row function? Absolutely. Say, for instance, you are interested in saying, okay, how many distinct car title and year do we have? You can use the distinct function to select it. And you can also achieve the same result here using the n, what's it called? N car. If you use n row and you just say, okay, how many rows how many rows do you have in the data set? As seen before, is 1,451. However, the distinct car listings and their car year, regardless of the state or whatnot, is 668 make of car. So the distinct function can let us know what are the distinct rows or records that we have in our data set. Not limited to what we've discussed under the row function, we also have like the tail. Let's say you want to select a minimum of 5 or you want to select a maximum of, the maximum value, or you want to select the minimum value, you can just use this function. They are very convenient to use. So now we've come to the end of verbs that is relating to rows. So we are about to move into verbs that is relating to columns. I think I should take a pause. So if anybody have a question relating to rows, you can ask so we can make judicious use of this time. And if not, you are comfortable in penning down your question, perhaps you don't have, it's fine also. Then we can continue accordingly. Thank you. Okay, I'm considering that thumbs up as no question. So if I can have like one more, then okay. Now I see. Thank you. So let's move on to column verbs or column operator for dplyr. These are interesting, and I guess you're just gonna use them. As a matter of fact, during the process of explaining the row functions or operators, I've kind of used some of these of verbs already. The select operators is just for you to select some specific columns. Interestingly, you can do your select in various ways, and I think this is where R shines than other languages. It's just super convenient for you to select columns. Super convenient, and can tell you that for free. And yeah, mutate function is for you to create. Okay. Oh, okay. Yeah, I think I got a question. He said Abiodun said, I want to understand why you show column type equals false when you were importing your data. Well, it's for convenience actually, and I can tell you what would have happened if I did not do that. So he's asking why I did this. So by default, read underscore CSV has this argument, show underscore column underscore type as true. So if I run this code, you're likely to see this function returning the list of data types I have for title, odometer, and the like like that, even while just running the function alone. But I did not really want that in this my example. So that's the reason why I kind of disable it, because I know later I'm still going to use the claims function to kind of like show the data type, which we have here as this, as well as some form of other information about the data. So it's super convenient for me to use glimpse rather than this function returning the column types. So it's just for convenience. It's not really a special thing. But I guess it makes your code cleaner sometimes, especially when you are going to do something like this later. Okay, thank you for that question. I really like it. That means you are really following for you to even pick that question. You're indeed following. All right. So the second column operator, um, you're welcome, boss. For the second operator, the mutate function, I believe if you are really a data wrangler or you are doing your exploratory data analysis, there is no way you will not use the mutate function to create new columns or modify an existing one. And not to say last, you also have rename function. So this is just, as the name suggests, you want to rename a column or something. So relocate becomes handy when you, in quotes, lazy to type all the columns that you want, or you use the select operator to specify the columns that you want. You just want to pick a column, then take it somewhere else, or pick a couple of columns and just place it somewhere else. And then you return it. We will get there soon. So let's go to the first one, the select operators. So this is just for you to select some columns that you're interested in. So we've been doing this since morning, I believe. So in the car data set, I'm interested in the title, the price, and the year. So I'm going to just say select title. So why I love her is the fact that I necessarily don't need to use backtick or quotation when I'm selecting my columns. I will only need or require this kind of preconditions if my column name has a space or a special character in them, say hyphen or space or something. That's when I think the backtick or the quotation start coming in. But R is super nice. You can just type the name of your column. So if you are using your keyboard, you can type things faster. And if you are using something like R Studio, the position they call it, or VS Code, you just get things done quicker, as opposed you quoting things and make your text. So yeah, so there are some good helper function when using select. As a matter of fact, I think you should explore this because it's going to make your analysis very, very fast. That's if you are not even using it before. But I know we have some experts here already. So yeah. That being said, you can combine select with this kind of helper function like start with. So let's say I'm looking for columns that start with ABC. We just combine it with any of other columns that I've selected earlier. So this is an example. Let's say I want to select all columns that end with ION. So all columns that end with ION. The way I'm going to use it is I really want the title to come first. So I do that. Then I say ends with, then in quotation, ION. So it's going to find all columns that end with ION. For this data set, we have the location and transmission. They end with ION. Equally, you can use the word start with. You can use the word as you can use an upper function contains. You can use, so for instance, let's say you are dealing with survey data or questionnaire, for instance, and your questionnaire is coded so that you have question A, question one, for instance, then you have like other columns for A, B, C, D, or subsection A, B, C, or something. You can just say, okay, you know what? Find me all columns in my survey data that is starting with Q1, meaning question one. And all the subsections, everything will just come together with it, since you're using start with. Another thing is perhaps you want to just mark some special character, let's say every first question, every second question, or something. Then you can use the where operator also. This is powerful. Perhaps you've not been using it. Let's say your data contains both numerical um, and numerical or character columns, and you are only interested in those that are numerical. You can just use where it's numerical or when it's alphanumeric or whatnot. Then if you just want to select your entire column, just say everything and you're good to go. So I'll just show us an example. Say in our data set, we want to select the title and we want to select all other columns that are numeric. In this case, we have odometer, mileage, price, and year. They are all numerical. As specified here, they have double type as their data type. All right. Again, you can also rename automatically your columns without explicitly calling the rename function. All you just need to do is use your select function and just specify the new name you want for an existing name. So the way it works is, I want to rename the time to be car model. I want to rename the odometer to be kilometers. And yeah, if I want to do that, all I just going to do is to say the new name equals the old name, the new name equals the old name, and perhaps I want to select other columns. Then in this case, I'm just selecting the top three. And you can see from the output, I have the new names for car model and kilometer. So that's why I said sometimes I just love especially with dplyr. It's just awesome. So what we did the other time, we can as well just do it again using this rename function. It's the same, and you're just calling the rename function extra. But I often don't use this rename. I just use select to just do my thing. Then you can also select your column using this position operations. So this what's it called? This how did I forget the sign? Column, is it column? Yeah, let me just call it column. For convenience. This column says select my first column to my fourth column. So you can also select your column that way. So you select your first four columns in that manner. All right, so the interesting one I said is this relocate. I find myself using this function a couple of times, especially when say you are building a Shiny package, a Shiny dashboard, and you really just want to select some things very quickly, and you don't necessarily need to specify or select them one after the other. You can just relocate some data. Here is an example. I want to relocate price and year to come before the title. We know that the title column is our first column. So as specified here, the first column is, we've renamed this. So it's title, next is kilometer, next is location, and it's imported. So let's say I want to select these two columns ahead of this car title. So I'm going to just say, okay, this column, put them before the title column. So as you can see, the result here. I believe I'm still audible. Please, a thumbs up will help and go a long way if I'm still audible. Thank you. Thank you very much. It means a lot to me. Oh, when it's spread your thank you, sir. All right. So yeah, let's now talk about mutate. Like I said, if you have not been using mutate, I don't think you've been using R very well. Mutate is super convenient. I imagine you want to do things like this. Oh, okay. Yeah. R starts at 1, not Python. Python starts with index of 0. Yeah. I imagine you want to do something like this in Python, for instance. It's not that very should I say, readable as this is. So I'm not even sure you will enjoy doing this kind of mutating in other languages as you would in R. So I think we use an assign operator in other languages like Python, but in R it's super interesting. All you need to do is just say mutate the new name or your new column. You're going to specify what you want to do. So say for instance, we want to calculate the age of our car and the current year is 2025. You just need to subtract any year from 2025 and you get how long the car has been made or something like that. So all you need to do is just say the last year, which is this year, 2025, minus the year column. So you don't need to do any other thing else. It's just going to create a new column for you called car age, and it's subtracting every year you have in that data set from 2025, and you have the age of your car. Again, let's say you want to calculate price in million. Say you want to know, okay, you don't want to display the thousands, the millions. You just want to say, okay, how much is it? So that you can say the price column is a million. And let's say another thing you want to do is, okay, if the car has traveled more than 10,000 miles or kilometer, that car is really like, it has a high mileage. And the thing you look forward to is when you're buying a car is you look for the one that has like a smaller mileage. So you know the car has not been really, really used, something like that. So I think I have a question here. Does the rename or select verb change a column name permanently? Yes and no. So if you do not assign it, like the output of the result, into a column, so into a new data frame, it's not changed permanently. But if you assign your modification to the same data frame, then the change is going to be permanent. So in this case, sorry guys, I'm going back a bit. In this case, where I'm just relocating this, since I'm not really assigning this output to any variable, then it's temporal. It's not really going to be permanent. However, if I assign this car to itself and manipulate it in such a manner, then it's going to be a permanent change. If that answered the question. Yes. Okay, so you're welcome. So I mileage, let's say I want to calculate the mileage status, and I'm saying, okay, if the car has traveled more than 100,000 miles or kilometer, that car has high mileage. If it is not, then it's just normal. So let's say I just want to have like two scales. So instead of me doing this with an if-else statement, all I can do is include it within my R this way. So there's another if-else verb or function. That one is if underscore else. It's still the same as this if else. I think it's just better or something. Or it's nice to see or nice to write. Finally, in this case, I've added 1, 2, 3 columns to my existing data set, but I am assigning it into a new column, to a new data frame. To that, the mutate has added 3 extra columns, and it is permanent in this new data set called car data underscore clean. So I can then use this car data underscore clean anywhere I want it. So in this case, I'm selecting the car age, the car price in million, and the high mileage status. So the syntax of mutate is straightforward. You say mutate, you pass in your first argument here is the data frame. Since we are using pipe operator, you can be sure that it's just going to be the first argument, which is super nice. The new column you want to create and the expression to create the new column. That's all. Straight and forward. Where it now become very interesting is for those who have like SQL background, the normal case when SQL statement can be easily written in R in this manner. Say, for instance, we want to create a car age category for that new data columns that we just created, which is the car age. And we want to say if the car's age is less or equals to 5 years, we can say the car is relatively new. If the car is less or equals to 10 years, it's kind of medium. Otherwise, old. So just pay attention to the syntax. I express myself with my first case and when. When this is met, then this. When this is met, then this. Otherwise, that is any other condition except these two, then just say it's old. So this would be a typical case of saying, you know what, if somebody wants to sell you a car that is very new at a very cheap price, you should be suspicious of that person. And equally, if they want to sell you an old car for an expensive price relative to a newer one, then you should know something fishy is going on. Another thing is, let's say I want to create another new column and I just want to know, let's say my budget is, let me be sure of this number, 2 million. Let's say my budget is 2 million and I'm looking at the entire car data set and I'm going to create some price category. And I'm saying something around, if the price is less or equals less than 2 million is within my budget. If the price is less than 8 million, of course, this condition, if true, the next condition is this. Is less or less than 8 million, then I can say it's a mid-range car. Perhaps I have 8 million that I still spend. Otherwise, I can say that car is a luxury car. So let's see the output. I think it's very interesting. So we have this Toyota. This Toyota is old. So that means this Toyota is kind of greater than 10 years and is less than 2 million. Yeah, maybe it's very budget friendly. And I have a Cora MDS, is old car, but the price is less than 8 million, but it's greater than 2 million. Hence it's mid-range. And this is luxury. So this is interesting. Mercedes GLK 350 is an old car, meaning it has been made more than 10 years ago, but the price is greater than 8 million. Yeah, this is a classic case of Benz because it's German made, people want it, and the higher the demand, the higher the price, something like that. So yeah, this can be a testament of validating some set of theory. So what have we done here? We've used the case when to create a complex flow of our data instead of using the if-else statement in a nested environment. And we just convert it to using a case when. Easy to read, easy to interpret as well. And I made mention of this true condition, saying if all the other conditions are being met, everything else will take this value. True means every other condition, just give it this last variable or last value that you want to assign. So I have a question for us. I think it was this an answer. I will have said, okay, what if we want to create price in million column showing in create a price million column showing price in million of naira. I think we've done something like that before. So I'm just going to expand the code and just show us how it looks like. So I'm creating a new column called price in million. All I'm doing is take the price of the car, then I'm dividing it by 1 million. And I'm selecting just the title, the previous price in whatever, and then the in its unit, and then price in million. So this Accra MDS is sold for, I don't know, listed for 3,315,000. So if I divide this by 1 million, then I have this nice output. But you notice that this has been like rounded up for convenience. All right. Yeah, I think we are done with the column operators. Please, do we have any question before we move to something else? And we've used 45 minutes already. Please, do we have any question up until this point? I know I'm fast. I'm sorry for that. Okay, so we are almost done. So,
Yeah, please, let's go
um,
ahead.
yes, thank you very much. So for the group by, this is where things start getting interesting. I will always encourage you knowing your rows, functions, or verbs or operators, then your column operators. Then when you're good, you can then come to using the group by and the summarize function. Because the group by, you can achieve it by featuring your data first, then apply your condition next. However, if you just want to do everything at once, then you can just use your group by function. Then the summarize function is a big thing. By big, I mean it's very powerful and you can use it to do a lot of things. So you can compress a lot of information into smaller chunk of information. Then the result is always combined automatically. So let's see an example is to extract car make and analyze them by import status. So our goal is to extract car make. So we can borrow this function from string R. Think of it this way. Let's say we have Toyota Corolla or we have Lexus EX or GX. So we can extract the first word. That word is a word is something that is separated by a space in a sentence, something like that. So we are extracting the first word in that title of the car, and that's how we achieve the first thing here. Like we extract the car make. Thereafter, so when you have piping, it's very interesting. You don't need to store this result into a new variable. All you just need is just continue doing what you're doing. Next is I'm now selecting this car make and I'm grouping by its import status. We all know that its import contain literally, is it foreign use or is it locally used? Then when we are done doing that, so we have created a bucket of car make and import status. Let me just put it that way. So we have something like Toyota that is foreign use. We also have something like Toyota that is locally used. If we can just see, let me highlight it. So we see we have Toyota, both foreign use and locally used car. So, but we are not done. We want to just get some summary statistics around them. For example, how many Toyota do we have that are foreign use? That's what we are using here as content. So this content is just counting things. It's not really doing anything special. We're just saying how many rows do we have in this data set that are that belongs to this group. Next, we also say something like, what is the average price per mile? Like how much price, sorry, average price in million, sorry. So average price in million for Toyota that are foreign use is we take the price, we divide it by 1 million to get price in million, then we take the mean to get the average. Then to that, this is important, I must say. So in cases whereby we have NA and we do not remove it, what will happen is we are going to have NA as result. So please pay attention to this. This is super important. Each time you are using an aggregate function within a summarize, ensure if you don't really want the NA to remove it when you are calculating your aggregate. Otherwise, this is going to come out as NA if any value is missing. That being said, let's compare results. For the foreign use Toyota, the average price is 0.12, but for the locally used Toyota, as you can see, very cheap, 2.6 million. But I just use the word cheap is a relative word. Let me just say it's cheaper than the foreign use. I think that's okay. But I'm not done. What I did was to say, you know what? Can we sort the number of cars that we have in this data set by the make as well as their import status? And that's the reason why this result comes this way. We could have rearranged it in another manner, say, arrange it by make. So in that case, we have Toyota coming together with the import status here. So yeah, that's how you can combine group by and summarize. But again, I don't think anybody will use group by without summarize. Like you are only grouping because you want to do some aggregation. But perhaps anyone here has used group by without any aggregate function. I will also be happy to learn. Why do I do
Yes,
this?
me.
So if I sorry, you have done so, boss?
Yes, I've used group by without summarize function.
Interesting. I would love to know your use case. Except you want to pass it to something else. I don't know. But yeah,
Yes, I use it to split the data by
when you are
group.
big, you are big. When you are big, you are big. Well done, boss. Okay. All right. Lastly, so we have this new variable called car summary. And what have we done, guys? We've first of all used the mutate function to create a make of car. So instead of having Toyota Corolla 20 Corolla this or Toyota Mazda, I don't know if I pronounced that well, or Mercedes GLK or Toyota Camry or whatnot. We just say, just give me the first one. That's the make of the car. So with this, we have created a new useful variable called make. Thereafter, we group by the make and the import status. Calculate some example is how many cars are both Toyota as well as foreign use, we have 562. We also calculate, okay, what is the average price in million? We could have the normal, it's easier to read and interpret when it's in million, so we know, okay, this guy is in million, something like that. Thereafter, we then use the arrange function, which we've covered not quite long, to arrange the count of the car. So we have the what's it called? The highest first, because we are sorting by in descending order. Yeah, that is about it for this particular guy. Other common aggregate function, which I often use, is the count function and the count aggregate. You can just use n just to tell you how much or how many rows do you have. You can also use n distinct to calculate distinct values in that column. You can use function for central, is it central? So yeah, measure of central tendency. Example, the mean, the median. Of course, you can do mode. Then you can use range, the mean, max, and standard deviation. You can also use positions like first and last. So think of it this way. You have your categorical variable. You can just pick the first one or you pick the last one. Since you cannot summarize or do a mean of male or do a mean of female, you can just say maybe pick the first gender or something. Then logic, you can perform logic in your summarize function like sum. You can calculate mean. I think we did mean the other time. Yeah, so let's put everything that we've learned so far with grouping together as one. Again, our goal is to extract the first word of the car. Next is we are calculating the age of the car, and we are saying if the car is less than 5 years, is new, otherwise it's older. So we are using both the make and the age of the car to now see, you know what, how much or how many old Toyota do we have, how many old Acura do we have in this data set? Can we calculate the average price as well? And we achieve that using this. So like I said, it's beautiful and easy to read. Even if you are not the owner of this code and it's given to you, you can follow it step by step. That is why I love dplyr. So eventually, I'm only selecting the top 3. That's the greatest rank. But this might not be useful because all I need to do first is to sort by count so that I can like first 3, or what I have to say, any car that has at least 3 counts of both olds and new can only return that car only in this case. So I've used mutate to create new variable. I've grouped by some set of variables. I've calculated summary statistics using summaries and some helper functions. And I've used filter to just limit the data to what I wanted. All right, so the window functions. Again, if you are from SQL, this is very direct. So let's say I want to rank the price of my cars. And again, of course, I'm going to create a group or the make of the car first. So to rank, I can just use row number. And I'm not doing this alone. I'm sorting also or ordering by the prices. So my my highest or the most valued car gets my first rank, and my cheapest car gets my lowest rank, something like that. Then I'm also calculating the average price per minute. But yeah, it's kind of straightforward. But you notice again here, I'm removing NA so that I can have like a good result. Okay, I'm getting tired. All right, so let's say we have this question that says find the average car age by location. And we have to say which location has the next car. I know by now we know what to do, so I wish I can use this to do like a practice question. So I will try as much as possible to move over this, and we can come to this at the end of the talk. This is muted. So yeah. Oh, I think I went back. Sorry. Yeah. Okay. Yeah. Perfect. So let's see a real world example and how a pipeline can look like. So imagine my goal is to filter out um, unrealistic price away from my data set. For instance, I'm just interested in cars that are greater than 500,000. Because the moment you start seeing a car that is 100,000, 500,000, either you want to buy the wheel of the tire, the wheel of the car, or I don't know what you're buying. And some cars are, let's say, above 200 million. If you have the 20 million rather, if you have the budget, yeah, that's the best for you. But if you don't, like, let's just select like a good price range. That's what we did here. So we took this. Next is we want to create or derive some variables. Let's say we still want to do some machine learning on this data, or we want to just create a nice visualization. So we can trim our data or standardize it. So here I'm creating first the age of the car. Again, I'm using the current year and removing, subtracting the years the car were made. So I will have the age of the car. I can clean the location by saying something like, if so I'm borrowing some some functions from other packages. So here you can see I've kind of like highlight where I'm borrowing the functions from. You can use the grepl functions, which is base R, to achieve this also. But again, remember, dplyr is also part of the tidyverse, so it's kind of like easy to use with other um, packages. I think I have a question here, but I will just come back and take the question. Lastly, I'm grouping by location and import status for comparison. So I've cleaned my data by location, then I'm checking them by their import status or import status. Yeah, summaries like what is how many cars do I have available for me? What is the average price in million? What is the age of the car? As in average age of the car. And I'm doing something like, okay, is it a good deal for me or is it a bad deal? Like, is the car less than 5 million? Let's say my budget is 5 million. Is the car like less than 5 million? And is it recently made? At least 2015 car. If yes, then let me see what are my choices. So I can see that, okay, if I indeed have this budget and I'm interested in these cars, I need to go to which area. So if I go to Abuja now and I want to buy foreign used cars, I have about 168. This case, I'm not even interested in the make. Let's say I just want a car. And I can see that I can still get some cars whose age is not too much, something like that. And I can know whether it's affordable or not affordable, something like that. Is it a good deal or is it not a good deal? So if it's a good deal, I'm counting how many cases whereby my price is less than 5 million and the car is less than 10 years. How many cars do I have that meets this criteria? That's what I have here as good deals. So in Lagos, I have 3 good deals. Good deals. Sorry, my English. In Abuja, no, I'm not going to find any. In Lagos, I can still see good foreign used cars that meet this my criteria and they are affordable. If I'm looking for locally made, I will have 4 of them. If I go to Ogun, I will see a a locally used car that means this my 5 million range and they are from 2015 and above. Yes, across the verb. Thank you. So nice question for me. So yeah, I think is that all I've got? I think that's almost all I've got. Okay, you can use your dplyr for your quality checks, just as we've been doing since morning. Like, how many NAs do you have? Do you have some cases whereby the prices are 0? Do you have some unrealistic years? In this case, we have some unrealistic year. The data, we are in 2025, and I'm also checking, do we have any data, any car that is made before 1990? And I'm having 9 cases of those cases. Remember, I'm using this operator, or in this case, so I'm saying can you find me cases whereby the year is greater than 2025 or the year is less than 1990? Remove any NAs and let me know how many rows meet this criteria. So that's what I hear. So this condition is going to give me true or false. If it is true, it's same as 1. If it is false, it's same as 0. So when I sum zeros and ones together, I can have an idea of how many rows meet this criteria. What else do I have for us? So these are just like real world scenarios, cases or conditions. So if I want to clean the data up, these are things I can do, and I really don't want to cover all this. Yeah. So I have other examples in this slide. So perhaps if any of our question demands for it, and since this slide will be shared, so you can see how I did some things. Okay, so let me summarize. The essential functions in dplyr is grouped into 3, though I did not cover the table one because I believe it's a bit advanced and I don't know the audience how they are, so I apologize for that. We have the row category, column category, group category. Then you can filter with rows, you can filter or arrange your rows, you can slice or choose the order of observation. For columns, you can select it, you can create new columns, you can rename it. For group, you can group by and carry out some aggregate function. We did a lot of piping to make our code readable and kind of smart or concise. Yeah, we should have like what should you have in your mind when you're using dplyr? First is think of the tidyverse, like tidyverse universe, tidy data. What observation do you need? If that's your question, you use filter. What variable do you need or columns do you need? You use select. Do you need to create a new column? You use mutate. Do you need to group? You use group by. Do you need to summarize? You use summarize. So it's as straightforward as that. So if you can have your dplyr mindset, I'm sure it's going to help you greatly with your exploratory data analysis. Very fast, very quick, and very readable. And your code can be collaborated. I don't know the English for it. So I have some questions that I would love us to have done. But again, let me just stop presenting here. Thank you again. I know I'm very fast. It's just that we have a lot to cover and I'm trying to manage our time accordingly. So the slide is there and I've tried as much as possible to make it like well commented or whatnot. Perhaps there's any question, you can let us know now. Okay. Yeah, let me just stop. I have other things like if you want to move to the joints across, like you want to carry out multiple operations, or you want to nest for advanced workflows. I really don't want to talk about that here because I know we can be bored with those, especially when I'm not doing live coding. I have a cheat sheet to share for dplyr. It helps because if you don't do this often, you might forget some things. But with that cheat sheet, I think it helps. So I'm going to drop that in the chat very soon. I will add it also to the slide. Of course, I'll get it across to the organizers and they can share. Thank you so much for having me. I'm so sorry. I'm very fast set off, but yeah, thank you.
Right. Thank you so much. That was a lot for us to assimilate, but thank you for sharing. I think people really enjoyed this section. And please, if you have questions, you can raise your hand. It was an amazing session. Thank you. The code. Okay, someone is saying it's a beautiful presentation. And someone wants the code, please.
The code and the slide are together, so you can always copy and paste from the
Right.
code. And I can share the code
Okay.
file as well, so make it easier.
Oh, that's fine. Thank you. Any other question, please? Okay. Thank you so much, everyone. Okay, I want to ask about tidyverse. Can you answer that, please?
Yes, I can. Just give me a second to show something. So tidyverse is a collection of packages that follows or love the tidyverse principle. So I'm gonna share screen now. So I think if you just go to tidyverse.org, I'll drop it in the chat as well, you have like the summary. So it's a universe for R packages for data science. And is opinionated, meaning they kind of like follow some set of guidelines, like, and the guideline is kind of straightforward. Like your data is kinder tabular form, or you structure it to a tabular form. Each row must be an observation. Each column must represent an idea. Yeah, and if it's pipeable, so example of tidyverse package is your ggplot, so they just fit in. And yeah, you can learn more about tidyverse here. So you have like dplyr, table, ggplot2, readr, tidyr, predate. So you want to do date things, you want to forecast, stringr. You can see I borrow some function from there. And you want to do some parallel processing, you can always use for. I think I pronounce it well because there's a cat there for something like that.
Right. Thank you. Okay, thanks for the link. Then someone said, I'll be glad if you can please help me with resource/roadmap tailored to health data science with R. Thank you so much for an awesome session. It's insightful and interesting.
Well, I intended to study biostatistics, so but I end up studying computational statistics. So, and I enjoyed more, and I'm glad I did not do the biostatistics. But in all, is there a tailored roadmap for earth data science with R? I think the first is you just getting yourself grounded in R, using R for data science itself. Where you will have edge is, I believe the person speaking is an health person or something. So your domain knowledge is now the health specific side of it all. So if you're asking for a tailored resource, I'll just say focus on using R for data science first. Thereafter, you can then start using your domain. Why you doing that first is your domain is your domain. You know the health things better than anyone. And when you want to start using specific packages for your specific use cases, it's kind of easier. And perhaps you want to even go under the hood and say, okay, what makes this work and what doesn't make this work? It's easier for you because you already understood the first part, which is R itself. So yeah. Yeah, I think that's all I would say, not to make it too big and general. Know R first, know how to use R for data science. Then you can then tailor it to your help. It's just that you're going to be using some specific languages or packages. I mean, say survival analysis, you might have some specific package for it. But I can tell you for free, if you know R and you understand the data science, you yourself can even write package. I know my Oga on Discord and build several packages. So yeah, but that's where your domain knowledge just shines.
Right. Okay, thank you. Okay, so Gloria, your hand is up, please.
Yeah, thank you so much for your wonderful presentation. Can you hear me?
Oh, yes, please.
Loud and clear.
All right. My name is Gloria. I joined from Germany. Yeah, my question is, if I want to kind of, for example, the year from the car data we used, maybe I want cars that are 2015 and above, that's greater or equal to 2015. Do I use the double equality sign alongside with the greater or equal to sign, or what sign do I use if I want something like that? I don't know if you got my question.
I did get the question.
Okay.
Thank you for that question. Yeah. The other time I was showing this. So your question is you want cars that are mod or made from 2015 and above, right?
2015 and above, yeah.
Yeah. So I think for that you just use greater or equals to 2015.
Okay.
Greater or
Okay.
equals to 2015.
Okay, not that I'll put the two equality sign, then pick one. Okay, okay. Thank you.
Though you can actually like do what you said you want to do, but since this exists, there is no need for you to do that. So you could just do something like year is equals to 2015, and by using this and operator, and year greater than 2015. But instead of doing it in those two cases, you can just say greater or equals to 2015, and it's just a single line. Yeah.
Okay. Thank you. Please, how do we get the recording? Will it be sent to our emails?
Okay, yes. So yeah, there's a link that is on the chat of the
code or
call,
so he
and
said it
yes,
has.
it will be sent to the mail.
All right. Thank you.
And
We'll
also
do
look
it.
out on the Meet page. If you are not there, please join.
Yeah, I'm there. I always get message. I join most of your programs. They are really wonderful. Fine,
Right,
in my
thank you
school
so much.
here, they are doing almost of these things, but when you learn from people in Nigeria, you know that there's a difference. Honestly,
Yeah,
I'm
okay.
having the lectures here, but when I learn from home, I get more understanding than the one they are teaching me here. It's really
Right, thank
helping. Kudos to you people.
you.
Keep it
Thank
up.
you. Thank you so much. Yeah, thank you so much, everyone. Please, any last question before we release our speaker? Okay, I'll be mentor to Babatunde. Okay, you have a mentor? So our speaker. Okay, thank you so much, everyone. It was great having you around, Mr. Babatunde Adebayo, and it was an interesting session. Good to have you, and thank you for honoring our invitation. And for everyone that
Just
joined,
mine.
I want to say a very big thank you. Thank you so much for joining. So watch out for the next session.